Perfect. Hey everyone, I will speak in English for no particular reason. Who here has worked on a team with more than 5 developers touching the same code? Everybody, awesome. Who here has ever called a function and got an unexpected result? Perfect. So I'm here today to troll about type systems. As a general rule, a type system is something that tells you this variable is this or that variable is that. Or in the case of web developers, it doesn't tell you any of that. It's basically not even really there. But, god damn it, Apple technology is not very reliable. So, who here, I'm guessing everybody has used a language with static typing, at least in college, if not ever in the real world. And usually, at least I know that when I started with static languages, I was like, fuck this shit, I'm not dealing with this, and I went to dynamic languages. Because usually static languages look a bit like this. Hey, do you want some, can you hold this? Sure, but what? What is it? Oh, it's just coffee, can you hold it? Why? Well, you know, I want to do something else with my hands. Okay, but what do you want from me? Just hold my fucking coffee. Okay, I will hold your coffee. Fuck! It's the wrong kind of coffee. And you're just sitting there and like, I just wanted to like say 1 + 1 = 4. What's the problem? Why are you making me do all this work? And so somebody came up with the idea of ducks. And the idea of duck typing is that you have a language that takes a variable and says, well, if this variable can do addition and it looks a bit like a number and it kind of does this and that, then it's probably a number and I can just do stuff with it. And this is where the infamous what talk comes from. Has everyone seen that? Well, it's basically a talk that makes fun of Ruby and JavaScript and makes a bunch of interesting examples like what happens when you add 2 arrays and you get an empty string, or if you add an array and an object, you get an object, but if you add an object and an array, you get not a number, which is technically correct. And when you have a duck type language, or pretty much any dynamic / weak type language, you get something like this. Hey, can you hold my coffee? Sure, I'll hold your beer. No, it's actually coffee. Yeah, I know, I love tea. And like, this is what and it's like, what's going on? Are you even listening to me? It's like, I'm trying to tell you what to do and you're just doing your own thing. And this obviously is, the comic is from Leftover Salad Tumblr, which I blatantly stole, and I honestly only found this comic like 2 days ago, but it demonstrates the problem perfectly. It uses Java and JavaScript as an example, and Java is probably the most famous language for horrible, horrible static typing. You have to keep telling it what the type of everything is. You have to, like, every time you declare a variable, every time you talk about a variable, every time you mention a variable, every time you even think about a variable, you have to tell Java what that variable is. And JavaScript is most famous as having completely bonkers type. It's not actually type inference. It just tries to kind of guess what it can do, and it usually gets it wrong. And Ruby, since we're at the Ruby meetup, is slightly better at that. It's still dynamically typed, but it's strong typed, so at the very least you can't add a number and a string, which is technically good. And just to recap, does everyone actually know the difference between dynamic and static typing? Are you sure? Because every time you go on the internet and you say dynamic typing is this and static typing is that, you will get at least 50 comments saying that you are wrong. And basically, usually what people think about when they say dynamic typing, they usually mean weak typing and so on. But actually, dynamic typing is just knowing what types are before executing. That is, no, that was wrong, see? Static typing is knowing what the types of things are before executing it. You have something that goes through your code and says, and figures out the types. And dynamic typing is you get runtime errors instead of type errors, which is also fun. But really, the biggest issue is that both dynamic typing and static typing, and both strong typing and weak typing, and you even get combinations of this, like you have C, which is weak static typing, which is just useless, if you ask me. But anyway, all of that stuff is really, really annoying. Either you have to keep thinking about types, or you never think about types and you get weird runtime errors when somebody calls your code and gives you arguments that you didn't expect. And a lot of the times when you start talking with people about types, they will tell you, yeah, but with dynamic typing you can write so much, you can solve so many more interesting problems, or you can do this and that. That is actually wrong. None of the various combinations of type systems are actually stronger than the other, because these are all Turing-complete languages and you can solve all your problems in any of the languages. So what exactly is the point of either typing or this talk? The point of typing is that computers need to know what they can do with certain things, and the point of this talk is that I just want everybody's opinions on how to actually use types and what kind of actually, are you guys happy with the languages you use in web development? Who here is actually happy with their tool set? Well, I guess it's mostly a mixed bag reaction. Like, few people raised their hands, nobody enthusiastically said, yes, I'm happy, and nobody started crying, which I guess is a good thing. But to go back to the question I had before is, the issue with types and all of these tools is really how big is your team. Because if you're working with 1 or 2 developers that you know very closely, what tool set you use pretty much doesn't matter. You can use anything you want. Code is probably going to work. Nothing unexpected is going to happen. You can usually agree on some sort of convention. But as soon as you start adding junior developers, or your team, or like 10 people touch the same code, you run into this sort of stuff. Who here knows what the hell those pluses are? So you have 5 plus 3 plus 2 is 151,022, and then you have a few different combinations of numbers with plus, and in the end the question, what happens when you do 7 plus 2 plus 5? And I don't think anyone can really figure this out by looking at the code for 5 seconds. And okay, this isn't really a problem of type systems, it's more operator overloading, which I personally think is even worse. Because the problem with operator overloading is that it looks cool, it gives you really clean code, but nobody will ever be able to know what that code does unless they memorize the whole code base. And usually, as soon as you get up to like 300 lines, you can't expect anybody to memorize the whole code base. And most code bases are like a few tens of thousands of lines, especially when you add the various frameworks we use. And it's like, don't use operator overloading in production, please. It's really terrible. And if you have a junior developer in your team, don't even tell them this exists, because they will use it and you will have trouble. But here's a more interesting example. This is from an actual code base that I used to work on. It's from a Ruby model. And what do you think this does? You have self-completed text, and it takes the argument successfully completed. You would guess that it takes some sort of Boolean argument and returns probably 2 different versions of a text, right? Does anyone disagree? Wow, so much for participation. Now if you look at the whole code, you can see that successfully completed actually gets cast to a string, And then if it's empty, you get an empty response. And if it says true or false, you get either completed or incomplete. And if you pass in anything other than that, you just get whatever you passed in. The hell? Like, how are you supposed to know this if you, like, let's say you have code completion in your editor of choice or IDE or whatever, and you write something dot complete, and it says completed successfully, and that it takes one argument, and you're going to be just like, yes, I'll just do that. And like, if you don't actually go look at the code, you have no idea what the code is going to do. And this problem is partially solved by unit testing. But the problem with unit testing is that if you're writing unit tests for this sort of crap, you're basically doing the compiler's job. Because this should be like, in a proper language. Let's say Ruby isn't the proper language at the Ruby Meetup. In a proper language, you would probably solve this with a polymorphism of some sort. You would have a function that takes various types of arguments and then does the correct thing. And you would always know the type of argument that goes into the function, and you would be pretty much happy. And you would probably get rid of something like 60% of your unit tests. Or, let's be fair, you would probably get rid of all of your unit tests and you would only keep integration tests, because really, what do you need unit tests for if everything just works as soon as it compiles? But to have a more interesting example, I think I've already used that phrase today. This is the result of a large-scale study that studied something like, I think it was 17,000 GitHub repositories, something like that. And they looked at different commits in different languages, on different projects, on different types of projects. And they tried to guess how error-prone a certain language is. More specifically, how error-prone a certain combination of language features is. And you can see that if you have a procedural, static, weak language that doesn't have memory management, you will get a lot of memory problems. And I'm guessing this is probably C, because at least I personally don't know of any other language that would have that combination. But more interesting is, up top we have dynamic scripting languages, which with weak typing versus dynamic scripting languages with strong typing. And they're not super error prone, but if they're strong and dynamic, which is Ruby, for example, they produce a lot of algorithmical type of errors. And this is essentially where you're trying to develop an algorithm, and you get something weird happens. You try to add a string to a number, and it just throws out an error, and then somebody has to fix it. And dynamic languages that are weak typed, and actually both strong and weak type languages, produce a lot of general programming errors, that is far to your right, and a fair amount of security errors. And like, this is all interesting. If you read the whole study, it basically goes through a bunch of different examples, and they explain their methodology. And there's some bias in the study, but I think it's interesting because it is one of the biggest studies that actually try to empirically show whether static or weak or dynamic typing is better or worse as far as how many errors you have to deal with. And the result can basically be summed up as functional languages are better than procedural languages, static languages are better than dynamic languages, and strong typing is better than weak typing. But there's a problem. It's only slightly better. The results of the study are statistically significant, but not by much. Because the issue is that really the biggest problem or the biggest source of error are the programmers themselves. So if you have very good developers, it essentially doesn't matter what sort of language you use, but they will produce slightly less mistakes if you use a strong type static language. But if you have a weak typed dynamic language, you they will produce like slightly less error, slightly more errors. But the bigger issue is that there's a high correlation between the type of developer that uses a certain language. And it turns out that weak dynamic languages have the worst developers, and strong static languages have better developers. And I wonder if that is sort of, like, this is a guess, but I'm guessing that younger people use weak dynamic languages because it's super easy and super quick to get something working, and people who actually need to get stuff done use languages that give them more, that are more reliable and are easier to use in that regard, even though you have to have an extra step of compiling, which is like, when was the last time you actually had to hit compile and your automation didn't just do that for you, right? I'm at a Ruby meetup, but you guys compile Sass and Less and all of that other stuff, and you probably merge all your CSS and JavaScript files into the same thing. So you do compilation, you just don't compile Ruby. So what is the actual solution to this? I don't actually know. I'm here to ask questions and to make you guys think. But I have liked how Haskell does things. It's static, it's strong typed, and it's got type inference, so you never actually have to tell it what type something is, because usually it knows better than you do. Whenever I'm coding Haskell, I usually just, if something doesn't work and it tells me that types don't match in my functions or whatever, I just delete the type annotations, run the code, and it tells me what type the function is, so then I just copy paste that from the compiler and put it back so that next time I read that code, I can know what type it is. Yeah, I think that's it from me. Go check out Leftover Salad, because I feel bad for stealing their comic, and you probably already know where to find me on Twitter. So, questions, comments, anything? Yes. TypeScript apparently is slightly less error prone than JavaScript, but nobody likes it because it's made by Microsoft. Microsoft and open source have kind of a rough history.
Have you used it? Tried it?
I haven't actually tried it, but from what I've seen, its biggest issue is that it doesn't have type inference. It goes the Java way of giving the developer too much work. And really, a big reason of why I think everybody or a lot of people go to dynamic languages is because they don't have to write types out. Because like if you do 1 + 1, like a equals 1 + 1, to you as a developer, it's extremely obvious that that is an integer. And you feel really annoyed when you have to tell the compiler that that is also an integer, because it should already know. And that's one of the benefits of things like Scala and Haskell, is that they do actually know that. And Haskell in particular has, like, you should, if anyone ever reads computer science papers, read stuff about Haskell's type system, because it's like, it's amazing what that thing can do. It just always knows what type everything is, and it's just amazing. More questions? Or comments? Yes?
You know, one language that you didn't mention, I work a lot in C#, and it can be either dynamic or static. You have...
How can it be either?
You have you say dynamic A equals, and it can be whatever some function returns. You can call one function that returns a string, or another function that returns a bool, and it will have a dynamic type. It will still have a type, but it can be whatever. So it's a dynamic and static language combined.
I'm not sure exactly how C# works, but I would venture a guess that's not actually a dynamically typed variable, but you have type inference instead.
No, internally it translates into a dictionary.
Really?
Yeah.
Okay, so it's a type class of sorts. Like, what can you change the type during runtime?
Yeah.
Or will it, or is it able to
say dynamic A equals 10,
yeah.
and say A equals 10 to string.
Okay, and so it actually dynamically changes
Yeah.
the type. That's pretty cool.
And it's also, this is not, you usually don't write a dynamic code, but in some cases you need to use it.
I'm trying to figure out where that makes C# fit, because Python, for instance, is a very dynamically typed language, but you can't change a variable's type after it's been defined. It's actually, I forget, I think that means it's strong dynamic typed or something like that. Basically, it means that you can't do A equals 10, A equals 10 to string, because it will say that A can't be a string or something like that, even though it's dynamically typed.
At runtime.
Yeah, you can do it at runtime. Cool. That's interesting. Yeah.
What do you prefer in Python? Which system do you use?
As I said, I'm really biased towards Haskell. My only problem with Haskell is that I'm not good enough at it to actually ever get to use it. And I don't know if it's just because I'm a bad programmer or because I haven't spent enough time with it, but most of the time I just end up battling with Haskell and never actually getting anything done.
Like the advice on how to learn Haskell is not to actually try to accomplish anything in particular, but just to play with it.
Yes. Yes.
Because this is the only way that you can sort of like internalize the Haskell concepts. Only after you've been doing this for like 6 months, then you can actually go and try to do something useful.
Yeah, and that is part of the reason why everybody uses dynamic languages, because you can just open an editor and the first line of code you write and you press enter and it just works. But the thing is that for actual real-world projects, I prefer weak dynamic type languages simply because it's easier to get developers for those languages, which is both a good and a bad thing, because if it's easier to get a lot of developers, that means you're getting more bad developers. And just JavaScript in particular is very widely supported on a lot of platforms, which makes it a very viable target for production. But it is paramount that you have at least somebody who is extremely experienced on the team, and the better unit test coverage you have, the better, because with languages like that, you can never have enough tests. Therefore, usually you have none. But yeah.
Would you say that for larger projects, either of those is preferable?
Yeah.
Really large,
like
100 developers.
If you have 100 developers, you will not survive in a dynamic language.
I also think so.
Like you will reach a point where anything anyone ever does is try to figure out what everybody else is doing so they can actually get anything done. Because the problem with large projects where you don't intimately know the style of every developer is that you can never actually know what any function does, or how to use it, or what to expect from it. Because documentation and comments will go out of date, unit tests will go out of date, and they will never cover every corner case. And the problem with runtime errors is that users see them, and you don't want that. The larger the project, the more errors there will be. And if you have a static language, you will catch a lot of those errors before users see them. If you use a dynamic language, a user will do something stupid and they will get a runtime error and everything will crash, and you will get a bug report saying this doesn't work. And that's all you're going to know. It's going to be impossible to figure anything out. Yeah, so the larger the project, the more important static typing becomes.
Okay.
Yeah.
So thanks again.